production possibility curve, right? So if you remember, I had asked you this question. Suppose that Swati has 20 hours of labor. She can bicycle and gather berries. It takes 2 hours to bicycle 1 kilometer and 4 hours to gather 100 berries. Which level or levels of production are efficient? I had given you these options. So now, and I had also asked you to let me know the resource, goods and technology in the above question, right? Okay, let me give you the answer. Resource is 20 hours of labor. Two goods involved are bicycle and berries. Technology is 2 hours to bicycle 1 kilometer and 4 hours to gather 100 berries, right? So that's the technology that has been used, right? Because that's the time that we have, right? Okay, so let's explore the options. 5 kilometer and 100 berries. 5 kilometer means that 5 into 2 because it takes 2 hours for 1 kilometer. So how many hours for 5 kilometers? So 5 into 2, that gives you 10 hours. And 100 berries, it takes 4 hours to gather 100 berries. So plus 4, so that makes it 14, right? 14 is less than 20. Now from where 20 has come, 20 is the total number of hours of labor that Swati has. So if she is doing the first option, then she is not fully utilizing all the hours of labor that she has. So that's an inefficient point in your production possibility curve. And I hope you know that where does it lie? It will lie inside the curve, right? So it will lie somewhere here. So if I have this, so it will lie somewhere here. Not on the curve, but inside the curve. That will be 14. Because any point on this would be 20 hours of labor. Correct? Okay. Then let's explore the second option. 2 kilometer and 400 berries. So again, 2 into 2 plus 4 into 4. So for 100 berries, it was 4 hours. So for 400 berries, it would be 4 into 4, right? So that gives us 16 and 4. So that's 20. That's efficient. Similarly, let's go with the third option. 10 kilometer and no berries. So 10 into 2, that again gives us 20 and no berries. So 0. She's not collecting any berries. So, but that's again efficient, right? Fourth is statements B and C are correct and none of the above. Since B and C, right, 1 and 2 both give us the options of efficient. They give us the efficient options. That is, Swati is utilizing all her 20 hours of labor. So these both options are correct. So second and third, basically B and C are your correct answers. So, your correct option is option 4. Statements B and C are correct. So 2 is nothing but your B and 3 is nothing but your C. Alright? This is how you have to solve for production possibility curve questions, right? Okay, so I'll go further into the topic and I'll start with production possibility frontier, PPF, or you call it PPC, or you call it transformation curve, or you call it anything else, right? It can also be called as transformation curve, transformation frontier, production possibility curve, production possibility frontier, all mean the same, okay? Alright, so what and how much can be produced, right? We drew this diagram in our last video, and we had these efficient points, point A, point B, and several other points out here. So that was, the point A was 20,000 and point B was 4,000. I am dealing with two goods, right? We have corn and wheat, okay? In this video, so we know that a production possibility curve or a frontier basically gives us all the efficient points, basically the combination of two goods that can be produced by fully utilizing our resources, right? They are efficient. Productive efficiency is given by all the points on this line, correct? Now in this, basically I'm explaining how to calculate opportunity cost, what is opportunity cost, and how do you go about calculating opportunity cost for each of the good. Okay, and I'm linking the productive efficiency to your opportunity cost. So first of all, let's just understand what an opportunity cost is. So opportunity cost of something is what you give up in order to get it. So it's a cost of trade-off. Okay, so if you want to go for a movie, and at the same time if you want to go to let's say shopping, okay, so then, and you decided to go for a movie, so then what are you giving up is your shopping. So that's your opportunity cost. So your opportunity cost of movie is your shopping. So whatever you are giving up in order to get it, in order to get something, that's your opportunity cost for that product or for that good. Okay, okay, you will understand it better as we go with the video. So in terms of this, so it's basically a cost of trade-off. Okay, so what is the cost of producing 4,000 units of wheat? So if I go with producing all the 4,000 units of wheat, then given the technology, given the resource, as discussed in the earlier video, I cannot produce any corn, right? So basically I have to give up all this 20,000 units of my corn in order to produce this 4,000 units of wheat, correct? So that's what the cost is of producing 4,000 units of wheat. 20,000 units of corn I give up in order to produce this 4,000 units of wheat, right? So therefore, the opportunity cost of 4,000 units of wheat is nothing but 20,000 corn units that you will be giving up, right? So opportunity cost for 1 unit of wheat would be your 20,000 divided by 4,000, that gives you 5, right? So your opportunity cost for wheat is nothing but 5 units of corn, or in other words, so basically this 5 units of corn is nothing but your opportunity cost of wheat in terms of corn, which basically means that for every unit of wheat, I have to sacrifice or give up 5 units of corn. So if I want to produce 1 unit of wheat, I have to give up 5 units of corn. If I have to produce 2 units of wheat, I have to give up 10 units of corn. If I have to produce 3 units of wheat, I have to give up 15 units of corn. Do you get that? Right? So 5 is nothing but the rate of change of corn and wheat. So in mathematical terms, it's nothing but the slope of this AB line, right? So change in y divided by change in x. Here y is nothing but your corn. So change in corn divided by change in wheat, right? So for every unit of wheat, I am sacrificing or giving up 5 units of corn. So it's constant, right? So 10 minus 5, 15 minus 10, so that's giving me the change, right? So every time it's 5. For wheat, if let's say this is wheat and let's say this is corn, then for each unit of wheat, so 3 minus 2 is 1, 2 minus 1 is 1, so the denominator is constant with 1. So 1 unit of wheat we are increasing every time. I am giving up, every time I'm giving up 5 units of corn, right? So that number 5 is constant, right? So your opportunity cost in this case is constant. Opportunity cost for wheat, right, is constant in terms of corn, which is 5 in this case. Do you understand this? Okay. Alright. So now this rate of change of slope is related to your opportunity cost of wheat. That's what I've been explaining, right? So in mathematical terms, the slope of line AB, this line AB, is nothing but 5, minus 5. Now from where the minus sign has come up, because it's showing the cost, what I am giving up, right? So I'm giving up this, so that's a cost to me, okay? In economic terms I'm talking about. Similarly, I can also have opportunity cost of corn, right? I can also have opportunity cost of corn, which will, in simple mathematical terms, it will be just the reciprocal of this, right? But okay, let's explain the way we have done it here. So, what is the cost of producing 20,000 units of corn? Now, for 20,000 units of corn, I have to sacrifice all of this 4,000 units of wheat. Right? I can produce 20,000 units of corn only when I have 0 units of wheat. So I'm giving up all this 4,000 units of wheat in order to produce this 20,000 units of corn. Okay? So basically what I get is cost of producing 20,000 units of corn is nothing but 4,000 units of wheat that I give up. So opportunity cost of 20,000 units of corn is 4,000 wheat units. For 1 corn unit, opportunity cost will be 4,000 divided by 20,000, which would be 1/5 wheat unit. So in order to produce every unit of your corn, you have to sacrifice 1/5 of your wheat unit. Okay? Alright, so with this, what we come up with an equation of your production possibility curve or frontier, which is simply given by, the equation of a straight line in mathematical terms. If I go about, it's given by your y is equal to a minus bx, right? So if I write it out here, it's y equals to a minus bx, right? Now y here I have on my y-axis nothing but corn, so it will be qc is equal to a is nothing but the intercept, right? So it would be nothing but your 20,000 minus b is nothing but your slope in this case, which is nothing but your 5 as we calculated, and x is nothing but your wheat, so it will be your qw. Do you understand this? This is your equation of production possibility frontier or production possibility curve. Now, any number that you take, right, in this equation will give us the efficient points, right? So if I am producing 0 quantity of wheat, let's say, then I am having corn as 20,000, right? If I am producing 1 quantity of wheat, let's say, then it will be minus 5. So 20,000 minus 5, right, QC. That will again give me a point on this line. So any number that you take on this line, right, will be the point on this line, and that basically means that it's giving you all the efficient points of production that can take place with these two goods and the given resource and the given technology. Do you understand me? So this is how, from production possibility curve or frontier, we can make out what and how much can be produced. Now if you want to produce entire only corns and in the most efficient way, then yes, we are here. If you want to produce only wheat and in a most efficient way, then we have to be here. If you want to produce a combination of the two, I can insert the numbers and I can be on this line anywhere, right? By that I will know, okay, I'm producing 20 units of wheat or 30 units or 100 or 1,000 units of wheat, right? And I will get the number for corn. And all these points will be efficient because they will lie on your production possibility frontier. Do you understand me? Okay. Alright, now in this case, the most important thing is that we had discussed this diagram and this example where we had opportunity cost as constant, right? So 5 was the constant number that I was giving up in order to produce 1 unit of wheat every time. I was giving up 5 units of corn every time I was doing that. Okay? But yes, there could be cases where we have increasing opportunity cost also, right? So increasing opportunity cost basically means that, let's take this example to understand. Okay, so you have different possibilities A, B, C, D, E. You have, again, let's say you have corn 0, 1, 2, 3, 4, and you have this cotton 10, 9, 7, 4, 0. Okay. Now it basically means increasing opportunity cost basically means that in order to produce 1 unit of a good, you are sacrificing more and more units of the other good every time you are doing that. So in this example, let's say, and by now I think you must have understood how to calculate opportunity cost, right? So it's basically your change in y by change in x, right? This would be your opportunity cost for your x. Remember that. Okay, this is really important to understand. When I'm talking of opportunity cost for x, right, then it has to be your change in y by change in x. Do you understand that? Right? Okay? Always remember that. So on the x-axis, whatever good you take, right? Whatever good you take on the x-axis, then the opportunity cost will always be on your change in y by change in x. Right? Okay. So in this example, I have taken corn on the x-axis and cotton on my y-axis, right? So if I am calculating the opportunity cost for corn, right, then it would be change in cotton divided by change in corn. Okay? Change in cotton divided by change in corn would be the opportunity cost for corn. Correct? Because that's what I'm giving up in order to have 1 more unit of corn. Okay. In this case, if we calculate, okay, first we go blank, right? Because there's no change. We don't have a previous number, right? Let's say we go with the second possibility of B, okay? Change in cotton would be what? It would be 9 minus 10, right? So that's 1. I mean, I'm taking an absolute value, okay? Because we know, yes, because it's downward sloping, we know that it would be a negative number. Okay, and then it's 1 minus 0, that's 1. So that's 1. When we go to the option C, then it's 7 minus 9, which is 2 minus 2, right? That means. And I have 2 minus 1, which is 1. So my opportunity cost increases from 1 to 2 for corn. Similarly, when I go with the fourth option of D, it's 4 minus 7, which is 3, divided by 3 minus 2, which is 1. So that's 3. 0 minus 4, which is minus 4, and 4 minus 3, which is 1, which is 4. So you see that every time your opportunity cost for corn is increasing from 1 to 2 to 3 to 4. That basically means that every time I'm producing 1 unit of corn, I have to sacrifice more and more units of my cotton. Right? So in this case, you won't get a production possibility curve as a straight line because the slope is not constant, right? The slope is increasing, so that's why you get a concave shaped slope. Okay, so that's why the shape is like this. It's outward. It's bowed outward. Okay, so these are your points. So for 1 unit, what you have is like 9 units, right? So that's a combination. So 1 and 9, 2 and 7, right? 3 and 4 and 4 and 0, and 0 and 10. All these points are again all efficient points that you get, but yes, you will have an increasing opportunity cost. So it basically means you are sacrificing more and more units of a commodity in order to get 1 more unit of your first commodity. Do you understand this? Alright, I'll continue with this production possibility frontier or curve theory a little bit more in depth, the advanced of this in my coming videos. Okay, till then, bye bye.